will do it some other way. Okay. So now we are given fyy here in this example. So given fyy, we are to find that is the PDF we are given. So given the PDF over here, we need to find the mean and the mean of the square and the variance of the random variable. So we have here the mean to be found. So mean is definitely, you can see that will just turn out to be the value, which is mu x, and that turns out to be integral of x fxx dx. So here it is y, so this is y over here, so this will become y 1.5 1 minus y square. Okay, limits are 0 to 1, right? So now we need to solve this, so that solving that will just turn out to be equal to, you can try to write this as equal to, and then integral 0 to 1 1.5 y minus integral 0 to 1 1.5 y cube. Okay, so with this value, again you can try to solve this, right? You can take a pen and paper and you yourself also try to solve this. So this will turn out to be here 1.5 y square with limits 0 and 1 minus 1.5 y to the power 4 with limits 0 and 1. So you can see that you will get y square is 1 square minus 0 square, y to the power 4 is again 1 to the power 4 minus 0 to the power 4. So either way, this will be 1 and this will be 1, and therefore 1.5 minus 1.5 will give us the value, which is 0. Okay, so the mean for this will be 0. Then you can find the expectation of x square or y square, because the variable is y here. So you'll get 0 to 1. This value will be y square into 1 minus y square. Of course, 1.5 I have missed it, so I'll write that 1.5. Okay, of course there is a dy also there. We should also write dy, right? Each time dy is necessary. Okay. So now you'll get here, I can separate it out, 0 to 1, 1.5 y square minus integral 0 to 1 1.5 y to the power 4, of course dy dy. I think have I made a mistake? Just check that. This is y squared by 2, right? This is y to the power 4 by 4 after integration. So this will no more be 0. This is wrong, right? This is wrong. So you'll get here half and 1 by 4. So that will be 1.5 by 4, right? So this will be 1.5 by 4. Okay. So now if you integrate this, you'll get 1.5 y cube by 3, 0 to 1 minus again 1.5 y to the power 5 by 5, 0 to 1. So that will give us 1.5 That is 0.5, is it? 0.5 minus 0.3, and that will give 0.2. So then you can find sigma x square variance in terms of, you know, this and the new value also. That is E of y square minus mu y square. So that will give us 0.2 minus, how much was that? 1.5 by 4. That will turn out to be 0.375. So this will be 0.375 square. So whatever result you get, that you can write over here, right? Whatever result you get, you'll get here. What is the value? Can somebody write it on the chat board? Point 0.2 minus 0.375 square. Can somebody write on the chat? What is the value? Is it minus? It cannot be minus. It's not minus, just check it out. It should be positive. 0.4 square is 0.16. So 0.375 squared is definitely less than 0.16, right? Okay. Might be 0.0593, right? Okay, might be that one, right? 0.0593, right? Okay, fine, no problem. Right? So once we find that value, we can just, you know, go to the next problem. I'll remove the annotation, and once I remove that, I can go to the next slide. Oh, this remains, so I should remove this. So how do I do that? So I'll clear that, right? We need to save this, might be. Okay. And then we can clear all the drawings. Fine. So now let us go for the question number 32. This is given as PDF is described by 1 by 8 z minus x for all values of z between 6 to 10 and 0 otherwise. See, really speaking, he need not have given you 1 by 8. He could have given you c into z minus 6 for all values z between 6 to 10. We have to find the value of c in the similar way which we have found earlier. Then you'll get definitely 1 by 8. But however, he has given you 1 by 8, so nothing to worry. So he has given you the range 6 to 10 and is 0 otherwise. What is the value of mean and what is the value of mean of the square and what is the value of the variance of the random variable, right? So I'll stop the annotation here. We'll see the formulas for mean and square for the case of discrete case which we have considered over here, and these are the things which we have here, right? These are the things which we have here. Is it discrete case? No, I don't think it is discrete case. It is still a continuous case over here. PDF is given and range is given. So let us try to, again, I'll start the annotation and start writing over here. So it is E of what you call x or mu x or mu z, is it? Mu z is equal to integral of z 1 by 8 z minus 6. Range of values are 6 to 10 now, dz. Okay, you can find the integration for this. So that will just give us integral of 1 by 8. I'll take it out totally. So I'll write a bracket here. Okay, then it will become z square dz minus integral 1 by 8 is taken out, 6z dz, right? So now I can try to solve that. 1 by 8 is common. This is limit is 6 and 10. So z dz is z square value with limits 6 and 10 minus, oh, this is z square, sorry, z cube by 3. Integral of z square is z cube by 3. Integral of 6z will be 6z square by 2. Limits are 6 and 10. Okay. So now I can try to find out that.
Power on.
So 10 cube minus 6 cube. So this will give me the value 1 by 8. 10 cube is 1000.
Connected.
Minus 6 cube is 216 divided by 3. Minus 6 by 2 is 3. Okay. Z square is 10 square 100. Minus of 6 square is 36. So I'll put it in bracket over here. Okay, 3 into this, because 6 by 2 will be 3. Z square will be 100 minus 36 if you put the limits here. So you can solve it and give the value. Similarly, you can find expectation of the z square, right? It's not x, it is z square. So that will be z square into 1 by 8 z minus 6 dz. 6 to 10 is the limit. I hope you can solve this. Similarly, now once you solve that, what is left is just sigma z square. That will be E of z square minus mu z square. Okay, you just need to write this and the square of this quantity. Okay, you'll get the values. I hope you can solve this. Okay, I hope you can solve this. So I'll just remove the annotation, try to solve that and find the solution for that. Okay. Okay, might be it is 1. You can just find out that and try to solve it. So again, I'll just save this screen and then clear the drawing. Okay. Then we'll go to the what you call. I think I should remove the annotation. Okay. Sometimes it creates problem. Okay. So we are trying to find this over here. Next is this. So it is given that Ex equal to 2.0 and that E of x square is equal to 6. Find the standard deviation of x. If y is equal to 6x square plus 2x minus 13, find mu of y. Okay, so again I'll start the annotation. So first a, right? A is very simple. Sigma x square is equal to e of x square minus ex whole square. Mu x is nothing but ex. So that is 6 minus 2 square, that is 2. So standard deviation is root of this value. Okay, then we have the b. So b is nothing but, we need to find mu of y corresponding to this. So mu y will be equal to e of y. E of y is nothing but 6x square minus 2x minus 13. So you'll get 6 into e of x square minus 2 into e of x minus 13. Expectation of a constant is constant itself. So 6 into 6 minus 2 into 2 minus 13. So 36 minus 4 minus 13. Is it all right? Okay, I think this is plus. This is plus. So 6 into 6 is 30. 2 into 2 is 66, and 2 into 2 is 30. 30 minus 13 is 17. Okay, so thus you can find the value. Similarly, you can find the ey square also, and then sigma y square also. That is not asked here, but that can be considered as an exercise also, where you can try to find e of y square and sigma y square. Okay, that's additional exercise which we can consider. Okay, so we'll try to save this and clear the screen, right? Okay, and we'll stop the share, stop the annotation, and then go for the next exercise. So next is random variable. The random variable x has the expectation mu x equal to, how much is this? 37.5, and it's not visible to me, 37.9, and sigma x equal to 10.3. The random variable y is obtained from x using y equal to this. Find ex square, find the mean of y. Okay, find ex square and find the mean of y. So again, we can try to solve this, right? So I'll just take the annotation. A part, we need to find this. What is given to us is this. So we know the formula. Sigma x square is equal to E of x square. So it's not writing properly. Why? Minus mu x square. It's creating problem. Okay. So this value is known, 10.3. Okay, 10.3 equal to this value is to be found E of x square, E of x square, okay, minus 37.9 square. So E of x square will be, I think might be my hand is wet, that's why it's creating problem. E of x square is equal to 10.3 plus the quantity which you have got, that is 37.9 square. Okay, that is how you can find this, right? So B is find the mean of y. So mean of y is just, it is given to us. Mean of y is E of y is equal to E of 0.6 x square plus 7.9x plus 107.1. So this will give us 0.6 into E of x square, whatever value we have just found, plus 7.9. E of x is mu of x itself, which is 37.9 plus 107.1. So whatever we have found here, you can write that, and that will give you the solution. Okay, so somewhere I might have not been properly writing the thing here. This is E of x square, this is 10.3, this is again E of x square, and this is E of square, and all that, right? This is mu x, fine. So this is E
power on, connected.
So this is how we can solve. So I hope rest of the thing calculations are quite simple. So you will do it, I'm sure. And I'll just save the screen and then clear the drawing. Okay. Then remove the annotation. Okay. It's not getting removed. Okay. Now it's removed. So then we'll go for the next problem. Okay. So now verify 2.56, that is E of z cube equal to 0, where z is the normalized Gaussian random variable. Then find Ex square is equal to the x equal to sigma z plus mu x. Okay. So we'll take the annotation again. Now, what is it we need to find? E of z square for the Gaussian random variable is equal to 0. So that is E of, sorry, zq is equal to 1 by root 2 pi integral zq e to the power of minus z squared by 2. Was it this? dz. Okay, I hope it is this. So you need to apply the integration by parts. The only way you can solve this is apply the integration by parts and try to solve this. This is, I think, limits is 0 to infinity. Just check it whether it is 0 to infinity or minus infinity to infinity. Just check that and try to solve that. Okay. So Z and 2 you try to differentiate by writing like this. Okay, so just to check whether this is all right, I'll remove the annotation and then go to the earlier slide. Where we have written Gaussian, where is it? Yes. Okay. So this is the equation for Gaussian 1 by root 2 by, okay, limits are minus infinity to plus infinity. Z cube e to the power of z square by 2 dz. So this is all right. Only I should write here minus infinity to infinity. That is the integration by parts you need to do. And again, it's just the integration by parts. And finally, using 2.23. 2.23 is, area under the PDF curve is equal to 1. The area under the PDF curve is equal to 1. If you use that property, you will be able to solve this. Try to solve this. If you are not able to do it, then I'll try to do that. Okay? Try to solve this. If you are not able to do it, then I'll do it. Okay, similarly, this is another thing, except that here it is z to the power 4. So 3 will become 4 and this 3 will become 4. And again, you need to solve it by the integration by parts. Process will not change. Then we have, different other problems. Okay, so I'll just delete this thing, annotation, whatever annotation I've done, save, clear, I'll do. So again, if you can see over here, you can remove the annotation. So these are just different problems which are given over here, and so we can try to solve all these in the same way, right? And see whatever given in the appendix A is correct or not for the Rayleigh's random variable. Okay, all that I think I might have shown in the last class in the video. You can just stop at that, or otherwise I'll just put the PDF of the appendix A. From that you can try to take this and try to solve and be ready for the next class, right? If you are if you can solve all this on your own, I'll be the happiest person. Otherwise, we need to solve some more problems in the next class. Okay. Similarly, once you finish with that, okay, so exercise for you is solving this by integration by parts, both these, and then solving all these numericals. Okay, Cauchy's, gamma, then Laplace, then Rayleigh. All these formulas you should use, and correspondingly find out whether they are right at all. Right? Given the what you call FRR, we need to find the value of whether where P is positive, verify the PDF mean and variance given in the. So you need to find the PDF. PDF is the differential of this. Mean is, once we find the PDF, you can find the mean and the variance. Only after finding the mean, you can find the, finding the PDF, you can find the mean and the variance. So first, PDF will be differential of this, right? This is the CDF, so differential of this. Similarly, CDF is given here. You need to find the PDF, that is differential of this, and the mean from the PDF and variance from the PDF. Okay. In each of the case, it is just the same. PDF for the gamma random variable is given in the appendix. Verify that the mean and the variance given are correct. Okay. Similarly, the CDF for the Cauchy's variable is given over here. You need to again differentiate this to find the value of PDF and also find the mean and the variance and find whether they are they exist or they do not exist. Okay, when do you say that they exist and they do not exist? You can try to find out. Okay, so we are left with very less time. If you have any doubts, you can put it on the chat. Okay, otherwise, I'll wait for 2-3 minutes and then we'll start. I'll stop the recording.